the right antenna for the right frequency and the right application. All right, so first up, we're going to talk about what is called Motus. I bet hardly anyone here has ever heard of Motus. It is not an acronym. It's actually Latin for the word movement or motion. So that's where it comes from. There's been lots of different ways that wildlife folks have tracked wildlife over the years, going back 50, 60, 70, maybe even 80 years in some form or fashion. But these days, the largest program on the planet is called Motus. What makes Motus special, because Canada is great, they've worked across the world to come up with unified frequencies. And so this is actually helpful for maybe those of us that want to monitor these, makes it easy. But for those that are doing things in the field, it also lowers some costs. So that I think is one of the biggest things. But as you can see on the bottom, there's a lot of cool things. And Motus has not been around for many, many years, but because it hasn't really been made very public, just to kind of throw some data points out here, I guess I'll just keep doing this. So countries with Motus receiver sites, 34 countries, over 2,000 receiver stations, 371 species, 46,000 animals, 800 different projects, lots of people behind it, 2,300 people involved. The point is, this is massive scale. When you have massive scale type of projects, you have massive amounts of data, and that's what we're going to kind of get into. So here is the current deployment map of receiver sites. I'm not going to spend too much time on this, but those magical 3 frequencies that we see up at the right-hand side, those are the 3 frequencies. It's really 1.5, I'd say. The first one, 166, is the most common. But the 434 frequency is growing in popularity. Not too much on 2.4 gigahertz. Most people know 2.4 is around Wi-Fi, so hasn't really caught on. But just kind of a local, picture as to how many of these Motus ground stations exist. Right here on Long Island, we're about 9. Connecticut has 17. Hudson Valley area, which is quite large, is 7, and North Jersey, home of Taylor pork roll, among other delicacies, is around 10. So there's a bunch of these ground stations. The way that you want to kind of think about these, the way that these ground stations get funded is mostly through academia. So if there's schools that are focused on ecology and environment, chances are they probably have some coursework that could relate to this. There's also a lot of other societies like Audubon and people into birds and stuff like that. So there's lots of different organizations that create these ground stations. If you could see how this map is a little different than the other one, where it looks like we have like these weird little butterfly type of things, the way that you want to think about these ground stations and how they detect birds is almost like a tripwire. So when a bird flies past the antenna beam width, that's how they know that there's birds that are coming past it. So most of these are dual band, so the difference between the yellow and the green is the VHF and the UHF frequencies. But every ground station has a different purpose for what it entails. If we're thinking local here on Long Island on the South Shore, down at the bottom, we can see that, I guess that's like Long Beach area-ish. So there's lots of birds like nesting piping clovers and whatnot that are endangered species down there. So they want to make sure where are they coming from. Most importantly, birds hopefully don't get in the flight path of airplanes. So you'll notice a correlation if you took a map of major airports and these ground stations, they strangely overlap. So kind of consider that a good thing. But that's a little bit about the ground station side. And then what does a ground station look like? Boy, we know Montauk and Boise, Idaho are like peas in a pod, right? So these are just 2 examples. Has anyone been out to Montauk Camp Hero? Anyone know where that is? Okay, so that photo that I have it right, if anyone knows where the bluffs are, to the east of the bluffs, there's a large receiver site. This was taken from satellite view. It's probably one of the larger stations because it's actually really important for different birds that migrate to and fro to Europe. So that's a really important one. And then just to kind of give a better up-close view is this one in Boise, Idaho. You can tell it's just like a solar panel with some 2x4s and an equipment cabinet with the antennas. So that's basically what a ground station looks like. All the signals from these ground stations do ultimately get ported back out over the internet, which I'll show you next. But what do these little transmitters look like? Birds, most birds, are pretty tiny. If we look all the way over at left, there's a US penny. So for scale, I tried to match things up pretty good. We're talking tiny because, again, they're going on birds. Here we have a dime with some other smaller ones. So again, these are really tiny. And what we're looking at on that map over there is this is a eastern whippoorwill. And this data I just pulled off the other day. So the way that this works is a bird will have a transmitter attached to it that's tagged by a wildlife professional. No, you don't go and buy these and attach them to birds yourself. Please do not do that. But these are for professionals to do this. And they track these. So what's kind of neat is this specific bird has a ID tag. So the way that these transmit, it doesn't have a GPS, but since we're just thinking of the ground stations as like a tripwire, every time that that bird has flown past these, it's automatically uploaded via the ground station network, and you can go to the Motus website and take a look at this data. And so here we can see that for some reason, this particular bird loves to spend most of its time in Rhode Island, but then sometimes goes down to the Jersey Shore, and for some reason likes to make part of its home in Washington, D.C. I don't know who wants to do that, but we'll keep politics out of this. But yeah, so here we could see for 2 years, basically almost what's the flight path of this bird. I think that's pretty cool. Now imagine if we're doing this for hundreds, if not thousands, of birds and other animals. So just to give a sense, and you can go and grab this. You can go to the Motus website and you could look at all this, maybe wherever you live, see what birds, if any, are tagged and tracked. So this is pretty cool. Here we have at the opposite end of the spectrum, this is one of the largest butterflies, but yeah, this is like CIA level spec ops stuff, right? Super tiny transmitter that can fit in the size of a US quarter. Currently we're around 2,700 birds that are tracked, which is the most. This is a sandpiper, followed by bats. There's a little brown bat. There's 646 of them tracked. And monarch butterflies, most of all insects right now, they're up to 423. So next time that you see a butterfly going past you, if you look at it carefully, you might see something and know it was not a CIA kind of deep cover thing. It's like a Motus project, so something to kind of keep an eye out for. So getting to the end of Motus, not going to go through these because I think I kind of covered these for the most part. So we talked about ground stations. Cool thing with the ground stations is the antennas are very directional. So most ground stations have 4 receivers. If anyone's into war driving, I would equate this to kind of like interesting for people that might be into war driving and maybe doing something different, but from a fixed location. So you do need a bunch of different receivers, which are, again, the same SDRs that you're all using. That's what these professionals are using to receive and pipe things in. The SDR is connected to like a Raspberry Pi. It runs a software pack down here called Sensor Gnome. I think that's the QR code. Somebody can validate it for me. If you hit that QR code, it should bring you to the Sensor Gnome on Git, and you can learn a little bit more about that. You can set up your own ground station if you want. All the details are there on the motus.org site, as well as other details. So again, I think this is really cool. If more people get involved in the Motus project through official organizations, I think we have a lot of good community and planet benefit. If all it is, all right, thank you. So yeah, I think if we can get more people involved in this, I think it's something that we kind of owe back to the planet. If we have a better understanding for our wildlife and their habits, that might be some good predictors of the future. So hopefully all those indicators are positive. But there we go on Motus. And now we're ready for Q&A on Motus. Is there any questions? If not, we could chug on.
Is there software out there you use because there's not much time? Repeat the question.
Yeah, so the question is there software out there? The answer is yes. So if you go to Sensor Gnome, if you just want to do a search for that, Sensor Gnome is the software that you could use to decode this, again, because they're unified frequencies. You could connect that to like a Raspberry Pi. You could run it on like a regular computer. Again, the key thing is antenna, but software, Sensor Gnome is probably the best one. There's a couple other splinter projects on Git, which is mostly all open source, but really easy stuff. Yes?
Two questions. Are those protected frequencies in some way so they're not used for other things? And secondly, how long do the batteries last in those
Yeah, so the frequencies are protected. So in the US, you know, we have this beast of an organization called the FCC. They kind of say what frequencies we should be using things for. These are protected. So things generally in like the 166 megahertz range are like usually federally licensed users. The interesting thing though on 434, for those that are ham radio operators, 434 in the United States and pretty much everywhere in the world, that's part of amateur radio spectrum. And so in that 433, 434 range, there's ISM devices. So everything needs to be low power, and any devices need to deal with interference from other users. And so other users could include ham radio people that are trying to bounce signals off of a moon or satellites and stuff like that, which are in that range usually. But we're also talking about things like wireless temperature sensors and weather stations and door alarms and all these other things in that. So that's why there's a combination of the two frequencies. In the rest of the world, yeah, again, this is all like, you know, try to mandate this, because what happens if a bird from here goes past Montauk Point and wants to go and spend its summer in Spain? They need to have ground stations that are on the same. And then the second question on how long do the batteries last? It depends on the animal being tracked. Some of these can last for a couple of years, because once they catch one of these to tag, they usually don't touch it again. Sometimes they don't last as long. It depends on what their application is. The faster that it transmits, then the less battery life it's going to have. And so that's why this tripwire approach is actually pretty cool, because they don't really care down to the day, to the hour, to the second when a particular animal crosses. They just want to kind of generally know. And so chances are if it transmits like a ping like once every 6 hours or 8 hours or 10 hours, chances are they'll have an idea. So some of these could actually last for quite a couple of years. Anything else? Bueller?